Good morning, good afternoon, everybody. Thank you for joining this webinar on production tools, why and how can Dialog help you with this? So we will be running this show with three people. My colleagues, Herman Moons will be doing the most of the talking. He's based in Den Bosch. I'm also based in Den Bosch. My name is Alex Kenge. I'm a product marketing manager. And in Greece, we have Vangelis, who's doing the questions, who's answering all the questions for you. So we will have three people running the show. So first of all, an introduction. I will go over it very quickly. Dialog is a global company. We are mainly based in Europe. We are European, headquartered in London. We have sales offices all over the world, major R&D centers. So I am based in the Netherlands, but my business unit also has offices in Greece and in the UK. We are a advanced mixed signal focused company, AC/DC power conversion. So if you have a laptop and a power brick to it, most likely will contain one of the Dialog ICs. We have business units focusing on custom mixed signal, so ASICs, also industrial mixed signal ICs, and I'm part of the connectivity and audio group, where we have technologies like DECT, Wi-Fi, and I'm focusing on Bluetooth Low Energy ICs. Next slide. So the Bluetooth Low Energy ICs, we are market leader ranked #2, sold over 400 million Bluetooth Low Energy ICs. We started out in, I believe it was 2014, with a very low power IC, and the applications are a wide range of applications in smart home set-top boxes, a lot of wearable designs, smart door locks, virtual realities, but also smart pens for mobile phones and activity trackers, you name it. Everything that can connect to a smartphone or a router with Bluetooth, we can provide ICs for it. Next slide, please. So I won't bother you with our product range, but this is an overview of the ICs that we have. So on the top line, we have the 600 family. It's our high-end with a lot of processing, but also low power. The latest one has a Cortex M33 sensor node controller, so it's a highly integrated device, even includes system, PMU, and a USB charger. On the bottom side, you see the 500 family, and the latest product that we have there is a very tiny device. It's also called the SmartBomb Tiny. And it's a M0 Plus based device, very small, even capable of handling a disposable type of applications. And to make it very easy, also made a module out of it. So this is a Dialog product, the DA14531 module, including flash, onboard antenna, and worldwide certification. So when you have these products and you want to make a nice end product out of this, how does this work? Herman will take you through the process of how you do your production testing and programming. Next slide. So Herman, floor is yours.
Thank you, Alex. I'm Herman Moons. I'm based in Den Bosch in the Netherlands, and I'm a customer support engineer. And I will tell you some vital information over the PLT. Welcome to the first line. Welcome to the production line tool webinar. We have an agenda with several topics, and at the end, something to win, conclusions. When you start you have successfully developed your application, and now you want to bring your application into volume production. How can the application board be prepared for this production test? So at the right hand side you see the drawing, you have an idea, application and software is made, and then production has to be taken care of, and then it's being sent to the customer. We consider in the testing the known good die principle, known good device principle. So you use good parts, good resistors, a good die, our die, inductors, and that kind of stuff. And it's being soldered on the PCB, and that has to be checked whether everything is okay. What do I still have to test? So in the brainstorm, I have to find out what do I have to test to achieve an expected quality level. And important is, what is the expected time and what's the expected cost during this test? And we have to break down, you have to start breaking down this test in test cases. So you do a brainstorm how to send up the production line, and take a piece of paper to write down the different topics, and mind that the brainstorm is a team effort. So many people have more ideas. So first of all, describe your production cycle. What do you plan to test at PCBA level, and what is to be tested in the enclosure? How do you plan to connect the PCBA, and what interface do you have available? And is there a need to store test results on a central server? Can be very easy. Or does the test system need to pull serial numbers from a server? So when you've more testers in parallel, it is possible that you need specific numbers that are being stored from the server into your product. If there are multiple test setups in the same room, maybe you need a shielded box, because shielded box will prevent noise coming in or a signal coming out, but that will interfere the neighbor. And here now the production line tool, the PLT, from now on, I mention it. It offers support for many production questions at a very low cost. So you have your application board. On your application board, you have memory, you have sensors, for instance, SPI sensors, magnetic sensors, I2C sensors. You have switches, you have buttons, LEDs, displays maybe, a beeper, a loudspeaker, analog inputs. You have nearly always you have your onboard radio, so you have your RX and your TX data being sent, and for that you need an antenna. Battery is used, maybe relays are used. You have general outputs, you have your general outputs for specific outputs, PWM parts, and you have customer specific things added on your application board. Why is the PLT made? Some years ago, customers asked us, can you help us in creating a production tool? And a large scale of automation was needed. And important, there was a request for a crystal trimming. Because crystal trimming gives you the option to select a cheaper crystal. In system programming of the use flash or OTP was asked for, and we started adding some functionality to test the RF. Of course, there are other signals, analog signals, and digital functionalities to be tested. The testing of the production line tool, the PLT, that looks like this. So you have here in the middle, you have your PLT. You hook up the PLT to the PC by using two USB cables. You use your power supplies. You have to, we chose in the past for external power supplies. You can use an external current meter. There you see the golden unit. Golden unit is a device that controls the whole board, and it has contact with the PC. and it has contact by using BLE via the antenna. It has contact to the DUTs. And here you see the antenna and the inputs. We have 16 channels as an input. So you see here the pin headers. And there on the pin headers, you have the connections to the power and the bus structure. In the middle, where's my mouse? Here's my mouse. Here you see the CPLD, which is a vital part of the PLT. And for the reference clock, you see here this TCXO. So the TCXO is vital for the crystal trimming reference. Keep that in mind. Some topics, crystal trimming without external equipment. It supports memory programming, OTP, QSPI, flash, and EEPROM. The RF testing is done by using the golden unit I just showed, and it can do the RX and the TX data transport. We have integration with industry standard RF testers, so the LightPoint and the Anritsu can be connected. The system is connected by using a USB cable and, for instance, an extension wire and an antenna. Current measurement is possible, so you use an external current meter, which is also connected by using a USB cable, and it's connected to the blue plugs. And so we have a flexible development to customize the tool for each specific application. Questions? I give the word to Alex.
So thank you, Herman. We will have some questions, partly to also keep you sharp on the content. So I will launch a poll now, and you can select one of the questions. So when do you start thinking about production testing? Please select one of the answers that are here, and later on we will give the results. I see that already 50% have voted. Thank you all. Still counting. Yes, so this is nice. So I will close it now and we'll share the results. So Herman, 22% say when the application design is ready, and 68% say it's running in parallel with the application design. What do you think?
No, I think the outcome is not bad. The good answer is the third one. It's a continuous process, the production testing. It starts from the beginning till the end.
Okay, thank you. So I think we already have another question.
Yeah.
So who is involved in the brainstorm? Let me launch this question. And there are multiple answers possible. So who is involved in the brainstorm of production testing? Is it the manager of design department, product engineer, product department, design engineer of the application? Please select who you think is. Yeah, I see. This is great. A lot of people vote. So let me close this question now and share the results. So most of the people think that the design engineers of the application should be involved. Some people say the manager of the design department, 70% say product engineering, production department. So Herman, what are your...
Yeah, of course, the manager of the design department, he pays the bill, of course, but everybody is involved. So the production engineer of the production department and the design engineers of the application as well. So everybody who has influence on the brainstorm of the production testing. They have bright ideas and use them. Use everybody's input. That's
okay,
my
great. That's
my
a
advice.
good. So this is good information. So we will proceed. Herman, the floor is yours again.
Thanks. What are the benefits of the PLT? Why choosing for the PLT? Now, the PLT is optimized to do production testing and for programming the memory. On the right-hand side, you see all the steps which are can be used in the software. On the top, you see the production test, and on the bottom, you see the memory programming part. We have a high level of parallelization, and it will reduce the testing time, and also the memory programming time. So it's done in parallel. That means if you use one channel, the time the test takes, it will be the same time as you use 16 channels. Onboard crystal trimming is supported. So crystal trimming is important because you put on a crystal, and on the physics of the crystal, the traces, the location of the crystal, how far is it away from your product, that determines the frequency. And we have inside a crystal block that is able to support the trimming by changing a number. And that's very important. We reduce the production costs. We have an excellent worldwide support. A large effort is put in updating the software. The source code is made available, can be found on the website. And the PLT will fit on all the Dialog BLE products. Yeah, we support all our products. So that's the 580 series, the 53X series, 68X series, and 69X series, and also future series to come. The low-cost Bluetooth smart application require an optimized production implementation, and Dialog has developed tester hardware to optimize that is optimized for ease and integration. DLLs are provided. We have a great flexibility in program OTP, QSPI, and EEPROM for the memories. But I already said a low overall cost of tester equipment. So for basic tests, you have your RF is on board, and your all your other stuff, the crystal trimming, all the other parts are built into the software or the hardware. And what I already said, we have a high level of parallelization, and that shortens the test time. The test concept is the known good device. As I explained, we are using components, you are using components on your PCB, and they have to be soldered onto the product, and we check the correct mounting of these components of the PCB by the testing. Easy steps to use the PLT. Here in the next slide, you see how it is done. First of all, in the middle, you see the PLT. And you connect your PC by two USB cables. You connect your power supplies. You connect your DUTs, 16 channels. And in most cases, a jig is used. So a jig is but I will show you later an example. It has pogo pins, so there are needles involved. They will, in most cases, they make contact with pads on the bottom of the PCB, and then the connection is made. The total is being put in a shielded box. It's optional, and not all the customers do that, but then you prevent noise coming in or noise sending out to the neighbors. Is important for testing, RF testing. We download the software from the Dialog website. We start the configuration screen, and here you see a shot of the configuration screen. I will show you later in a short show how this configuration screen can be used. We start run, and we start the test. And here you see the main screen, what the operator sees in production. And at the end, we see when it's passed, you see all green blocks. You change your DUTs. Most of the DUTs are being put on panels, and you have 16 application boards being put on a panel, and you take the panel out and you put a new panel in, and you close the lid. Pogo pins are connected to your panel, and the run can be started again at here at the top at number 9. And this is a continuous process. Showing how easy it is to set up a PLT environment. So here you see a PLT board. You connect power supplies, so you only need 3 power supplies and the ground. Connect the USB cable to the GOL unit. We connect USB cable to the all the FTDIs interface here, so all the channels are connected by using a UART. Here's an example of the board seen from the top. Here you see all the interface cables. They look a lot, but every channel, in this case, a panel is shown with modules. So here you have your socket with the Pogo pins. You put your panel in the socket. You close the socket and you close the hatch. And then from below, the connection is made. Dimension of this one is our module. It's only 1.5 centimeters, so 15 millimeters in square. So this is really small. And this one has only 3 connections to the PLT. So in this case, you see a lot of wiring, but only 3 connections per DUT had to be made. Then we set up the GUI, so the product engineer will put in the proper settings for the GUI. We start a production screen and the system will start running. We check the results, and when the panel is okay, it's okay. When it's not okay, put it lay it apart and do some checking and continue. What to be expected of the PLT? We have 16 channels. So the test time will be relatively 16 times as low. Simple connections, 2 times USB, 3 times power supply. We have login screens. I will show you later what the log screen looks like. Source code is made available, it can be found on the website. Many users, we have hundreds of users. Real-time logger is on board. Onboard radio. So the onboard radio is here, is located here in one of our chips, the 580, and it's hooked up to the antenna, and that's taking care of the testing. So no external equipment is needed for basic testing. However, it can be done, it is not needed. We only have a few wires to be connected. So we have the VBAT and ground, TXD, RXD, and for the module, for the 531, for instance, we have only 1 wire. For the UART, we use the 1 wire, and we can attach the reset. Normally, it's not needed. We do the power cycle. We turn on the power, and then automatically the power and reset comes in. Hardware is cheap, and the software is free of charge. Yeah, we have the GUI and the command line interface as software tools. And yeah, we have excellent software and hardware support worldwide. And yeah, we have a modular approach. So the PLT offers a complete set of test functions, and customers can add their own. Support test functions. So we support all our products. We show yield information. Debugging is possible. We can program OTP, QSPI, EEPROM. The configuration is done by UART boot pins. UART baud rate can be set. The sleep clock can be checked. The SPI memory can be filled, and the EEPROM memory can be set. Hold on. We have a standard setting of SPI memories, EEPROM memories, but you can add your own setting as well. BD addressing. This is the Bluetooth device address. The BD address. It can be standard incremented. It can be done by a range or from a file, or we can even use a barcode scanner. I don't go into details, but these things can be used. Test settings. We have possibilities to test GPIO testing, sensor testing, custom testing. So when a customer has specific test, which he wants to keep as a secret, he can, and he just puts it in the software, and we can make contact with that software, and it gives a pass or fail. Current can be tested. So on the blue inputs, an external current meter can check the deep sleep, the extended sleep, and the active current, for instance. And we have test setting for the crystal trimming. Yeah? So the crystal trimming can be done by this board without using external equipment. Watchdog can be tested. Oops. Scan testing and RSSI. RSSI is signal goes from our PLT to the product, and the scan is it goes from the product back to the PLT. So then we check how the antenna connections are. And also we can use external RF testers. Hey, a new question, Alex.
Thank you, Herman. So next question for you is, and I will share the question is, what memories can be programmed by the production line tool? So please answer this question. So I still see that people are voted. Oh, this was a really easy question, Herman.
Yeah, this is so easy that there is a trick. Yeah. Where of the trick?
So 90% say it's all of them. So that's actually true. You can program all of the questions.
We have a second question.
And there is another question on this, and this is about the external equipment. Let me launch this one. So what kind of external equipment do I need to do crystal trimming? This is a more difficult one. So do you need external equipment, counter connected? Frequency generator. Herman, this is also a really easy one. I see now that people, 80%, they have chosen that there is no external equipment needed to do crystal trimming. And that's a real benefit for the PLT, yeah, Herman?
Yeah, that's one of the great benefits. We're produced by an internal TCXO. We produce a 500 millisecond pulse, and that pulse is added to the DUTs. And by using a special test software, the proper crystal trim level of value is calculated, and that's being stored into, for instance, OTP. That's a real benefit. Yeah.
Okay, great.
Okay, then we can continue. We have here the block, the software block diagram. It's a modular setup. You see here the configuration screen is important. Where is it? Where is my? Oh, here it is. Configuration screen is important. That's what the product engineer deals with. The GUI, so the test screen is important, and CLI, for instance. What also is the params XML. We use a specific file. The customer doesn't see it, but and all the inputs and outputs are the configuration is being set. So when you have to change production, take your other params XML, and you have your complete system being set up. Also for debugging and when questions are being asked to us, we always ask for the params XML, so we have the complete setting of the system. External equipment is being used in this case. So here you see the voltmeter. A multimeter can be hooked up to the system, and here you see the Aretsu and the light point external RF testers, which are standard software is available for those. And the source code is made, the source code to run this complete software, PC software, is made available on the website. Yeah, this is the software. You can use the command line interface. Here you see the picture, and the console application for integration into third-party production tools can be easy. My favorite is the configuration screen, so that you can set up as a product engineer. You can put in all the configuration values, and this is the main production screen for the operator. And now I will show you a small example. I hope you can drag me this. So I hope you can see my configuration screen. Here you see the configuration screen. You can set up how many products you can put in. UART interfacing is taken care of, and we have some statistics can be set, settings of the product. That means production testing, memory programming, and then we go to BD addressing. We have several ways of handling the Bluetooth device address. Every product has its own address, and we have several ways of incrementing the address number, or what customers have maybe their own list of addresses, and they can be handled by the system. Here we have the hardware setup, so we can set the system, which UART is being used, which speed of the baud rate can be used, and some settings for the specific SPI memories, etc. Test settings, important is the crystal trimming, for instance. Crystal trimming is, where is he? This is the crystal trimming. Crystal trimming is a vital part. You can just enable it. You can set the input port, and the principle is that a pulse is a 500 millisecond pulse, for instance, is going to the product, and the system inside will react on the pulse, and that's the reference pulse, and then the crystal trim value is calculated. We go down, scan testing. Here the RF testing is important. Here the RSSI, for instance. When you do an RSSI test, 500 packets are being sent from the golden unit to the different DUTs, to the 16 DUTs. They receive it, they calculate the strength, and then they see, okay, it's -40, it's -30, and they know, okay, the antenna part is working well. Suppose one of the parts is not soldered well, you immediately see that the level will drastically go down, and the system detects that, and it will give a fail. You can choose your own frequency to do that test, and you can program up to 10 tests yourself. Also possible is that you can use your BLE testers. So you have here the possibility to choose for different for the light point and the Anritsu. So the RF testing is really important. Here you see the other stuff I mentioned already in the past. Here you see the possibility to use the different memories, OTP, SPI, and EEPROM. And the memory header is taking care of that. I will show you a small run, give you a run. Hold on. So here you see my main screen. So I start my testing. I have connected two channels, sorry. And you see crystal trimming is done now, and scan testing is done. Here RSSI is being tested. Downloading of the SPI is done, and in 16 seconds now 2 channels are being tested and downloaded as software, and The same time is for 16 channels. And you have here a lock screen. So in the lock screen, you can see, I hope I can see it, but in the lock screen, you can see what values you see here. The crystal value is 79. Ours is BD address locations. RSSI values can be shown. So all the measurements that are being done are shown in this screen. Okay, that was that. I go back to my slides. Next slide. A conclusion. Why choosing for PLT? It's a turnkey solution for testing and programming of your Bluetooth application. High level of parallelization will reduce the test time and the test cost. Very important. Modular approach, allowing customizations, and we have excellent worldwide support available from Dialog engineers. Source codes are made available to make it easy to adapt your own test, and many hundreds of customers using it all over the world. Links to the site. So here you see on our website you can find the user manuals. The software can be found of the production line tool, and the schematics, even all the hardware is available. So when you want to do some designing, whatever on the PLT board.
So thank you all, and I hope to see you next time on our other webinars. Thank you again.